Hello everyone, this is part 2 of the computer science question paper, and this video we will be covering questions from 11 to 21. Let's move on to the 11th question. Okay, in this question we have given a relation and we have given a query. Okay, and we are asked that what would be the number of rows which is written by this query. Okay, so see, the first statement of the query, it is select s dot rating average s dot age as f gauge from sailors. So this is our sailors. In this we have 1 to 4 attributes. Okay, so after executing the first line of the query, okay, we would be getting two attributes, that is rating and f gauge. Okay, that is average is written as f gauge. That is, we would be getting this rating and average of the age. Average age. Okay, so in our output there would be two attributes. Okay, that is rating and f gauge. Okay, now but what is asked is number of rows. What would be the number of rows which would be returned? Okay, in the second line it is told where s dot age is greater than or equal to 18. So we would be discarding all those rows where the age is not greater than or equal to 18. That is this one, 17, 16 and this. So these three tuples would not be included in our final result. Okay, next let's move to the next line, that is group by s dot rating. That is, grouping is done on the basis of rating. Okay, it is done on the basis of rating. Now here, having 1 less than, select dot count from sailors, count all from sailors s2 where s dot rating is equal to s2 dot rating. What this query returns? This query returns that that we would include only those record where the rating is more than 1. For example, let's move 1. Suppose the rating is 1 here. Okay, so there is no more 1 over here. So we won't include this. So we would exclude this. Okay, next 3. So we have 3 entries here. These entries would not be included in our output. These 2 entries would be included. So first tuple would contain group by rating. So we would contain 3 and average of 26 and 64. So this would be our first tuple, that is 3 and average of 26 and 64, it is 45. Okay, now next greater number is 7. 7, we have 2 7s over here. Okay, so our second tuple would contain 7 and average of 35. Our second tuple would contain 7. Okay, and our average of 35 and 45. That is 7 and average of 35 and 45 is 40. Next greater number is 8. See, okay, we have 2 8 over here, this and this. So our third tuple, it would contain 8 and average of 55 and 25. That is 8 and average of 55 and 25. Okay, let's move on to the next. Next higher number is 9. But we have only 1 9. But here, according to this statement, there should be more than 1 9. Okay, so it is not, we won't be taking this into consideration. Okay, next move on to the 10th one. 10 over here, 10 is over here. This tuple we won't be including because age is less than 18, and 10 is over here, we would not be including because age is less than 18. So this would be our answer, final result. That is, it would contain 3 rows, that is 3 tuples. So answer should be D. Okay, next move on to the next question. In this question, there is a relation given. Customers is a relation in which we have 4 attributes: customer ID, name, gender and rating. Okay, the rating value is an integer. The range is from 1 to 5. Rating we have, it is from 1 to 5. It is fixed. Okay, it is fixed. And only 2 values are recorded for gender. So gender is also fixed. Male we can take as 0 and female we can take as 1. So it is also fixed. Okay, for rating we have 1, 2, 3, 4 and 5, and for gender we have 0 and 1. We can take 0 for male and 1 for female. So consider the query, how many male customers have rating of 5? So it is like male customers, so it is gender, okay, and have the rating of 5 rating. So it would range from 1 to 5 rating, and gender would be either 0 or 1. So all the values are fixed. So the question is, the best indexing mechanism appropriate for this query is, okay, when we have fixed values for any attribute. For example, for gender, the value can be either 0 or 1, and rating, it can be either 1 or 2 or 3 or 4 or 5. Apart from this, apart from 1 to 5, there can be no other values. So for both, in our query, for the both attributes, the values are fixed. So we would be using bitmap indexed. When the values are fixed, then bitmap index should be used. It is the best option. So our answer is D. Okay, let's move on to the next question. In this question, we have, consider the schema, we have 3 schemas. Okay, sailors, boat, reserves, 3 schemas I have. 2 boats can have same name, but the color differentiate them. Okay, 2 boats can have same name. Okay, now this is our 2 relations. Okay, and they are saying that this is a division operator, and we have to see the output of these 2 relations. Okay, let's have the first. Okay, this is a rename operator. Okay, it is a rename operator. This is a rename operator. So we would be renaming our resultant. This is our final schema. We will be renaming this final schema as temp SIDS. Temp SIDS. Okay, temp SIDS. Temp SIDs, we will be renaming the final schema as temp SIDs. Okay, this operator is done. Now here, in reserves, we are having SID and BID. Reserves, we would be having SID and BID. So we would be having SID and BID. Okay, so, all the SIDs and BIDs would be there, and this operation is divides. Okay, so what we are getting here is, for all, we are selecting from boats, we are selecting all the boats whose name is Ganga. Okay, and we are projecting only the BIDs of all the boats whose name is Ganga. Okay, in this we are selecting the BIDs of all the boats, BID of all boats whose name is Ganga. Okay, we are taking this only. After performing the division operations, okay, so what would temp SID contain? Temp SID would contain the SIDs and BIDs of all the reserve boats whose name is Ganga. Okay, from this we have all the BIDs. Okay, when the division operation is performed over here, all the BIDs of Ganga only. In this we have all the SIDs and BIDs. When the division operation is performed, the temp SIDs would contain all the boats, all the SIDs and BIDs of the boats whose name is Ganga. Okay, now we have SID and BID in temp SID. Okay, and of the boats whose name is Ganga. Now what we are doing is, we are performing a join operation between temp SIDs and sailors. So this is our temp SID relation. Okay, and this is our sailor. So temp SID contains SIDs and BIDs of all the reserved boats whose name is Ganga, and sailor contains SID, name, rating and age. So the joining attribute between these two would be the SID. We would join this with the help of an SID. So final attribute would contain SID, final schema would contain SID, SName, rating, age and BID. Okay, of all the boats whose name is Ganga, of Ganga. We can written as of Ganga. Okay, now what we are doing is, we are just projecting the S name. So what we are doing, we are projecting the name of the sailors who have reserved all boats called Ganga. Name of the sailors who have reserved all boats called Ganga. So it is here. So A would be our answer. Okay, see, there is a shortcut. Whenever there is a division operator, in this case you have to check for all. Generally this would be our answer, but you have to otherwise solve everything. Okay, next, type 4 JDBC driver is a driver. Okay, there are options. Let's see, there are 4 types of JDBC drivers. type 1, type 2, type 3 and type 4. The type 4 driver is called JDBC ODBC bridge driver. Okay, this is not written in Java. It is not written in Java. Okay, so it is less portable. Okay, it is used for database connectivity generally. Type 2 driver is called the native API driver. Okay, it translates JDBC function calls into API non-native to DBMS. Okay, it is also not written in Java. So both type 1 and type 2 are not written in Java, so they are less portable. Portability is less. Okay, next, type 3 driver or the network protocol driver. It is called the network protocol driver. Okay, type 4 driver is called a thin driver. It communicates through Java sockets. Java sockets. Okay, both type 3 and type 4 are written in Java and they are portable. Okay, this is a basic thing. You can go in detail about all the drivers. So let's move on to the question. Type 4 JDBC driver is it is written in C. No, our driver type 4 is written in Java. Okay, it requires, okay, type 4 does not require intermediate layer also. Intermediate layer. So our second option is also not true. Okay, third option, it communicates through Java sockets. Yes, it is true. Fourth, which translates JDBC function calls into API, not native to DBMS. It is the function of type 2 driver. Okay, it is called native API driver. Type 2 driver, it is type 2. Okay, so answer is C. Type 4 JDBC driver is a driver which communicates through Java sockets. So this was, you can go through detail about all the drivers. Okay, so this was the basic thing. Next. 15. Okay, consider the following table. This table is given already. It is given. Okay, assume that this is a table and this we have five attributes and we have some rows and we have some data in it. Assume that no faculty member within a single department has the same name. Okay, all the faculty members within a department, they have different name. Okay, each faculty member has only one office identified in office. Okay, 3NF refers to third normal form. Okay, now this is a question we have to see which is in 3NF and which is not in 3NF. Okay, so from this relation, we generally have two non-trivial functional dependencies. We have two non-trivial functional dependencies in the given table. Let's see. Okay, see. First is the faculty name. Okay. First is the faculty name. It can be written as faculty name, department, office, rank and date head. This is a non-trivial functional dependencies. Okay, you can go through some notes on how to find non-trivial function dependency in a given table. Okay, so I will be giving you directly. So faculty name, we have department, office, rank and date head. It is the non-trivial function dependency for the first one, and the second is the office department. These are two non-trivial function dependencies. Okay, given in the table. Okay, now see, read this line. Each faculty member has only one office identified in office. So every faculty member has one office identified in the office. That means the name of the faculty is the primary key. Okay, this is the primary key, name of the faculty. Fact name is the primary key. So if fact name is the primary key, it can be considered as a super key. Every super key is a primary key. We select a primary key from set of super keys only, no? So if the faculty name is a primary key, then it can be considered as a super key. So it is a super key. Okay, now see the first functional dependency. Let's move on to the first dependency. According to the first dependency, we have it is in 3NF as well as in BCNF. The first dependency is in BCNF as well as in 3NF. Okay, how? Because faculty name is primary key as well as it is a super key. Okay, so the first non-trivial functional dependency is in 3NF as well as in BCNF. Let's see the second one. The second one, see, it's not in BCNF. The second version is not in BCNF because second is not in BCNF because office is not a super key. Because office, it is not a super key. Not a super key. Office is not a super key. So it is not in BCNF. But in 3NF because office is a prime, because department is a prime attribute. Department is a prime attribute because we know department is a prime attribute. Department is a prime attribute. Okay, so we have what we have did is we have constructed two non-trivial, all the non-trivial functional dependencies. In this relation we had two. The first dependency, it was in 3NF as well as in BCNF, but the second dependency, it was in 3NF but not in BCNF. So our table as a whole would be in 3NF but not in BCNF. So answer would be B, in 3NF, not in BCNF. Okay, next. Okay, this is select E number and count star from employee E group by E number. Okay, if an index on E number is available, the query can be answered by scanning only the index F. Okay, see, we are grouping it by E number. Okay, so hash would work. If we make some hash function, that would mark it to the E number. So hash would work. Okay, even B plus tree would be there. B plus tree would work. Okay, B plus tree with the clustering or without clustering, both would work. With cluster or without cluster, both would work. Okay, so the answer would be, it is, I think C. C is the answer. Okay, it can be hash or B plus tree or clustered, unclustered or non-clustered. So B plus tree clustered and non-clustered can be there because we are grouping it according to the employee number. So it can, even if it is clustered, it would work. Even if it is non-clustered, it would work. Okay, next. Okay, we have C is a skew-symmetric matrix of order n. So C is a skew-symmetric matrix of order n. So what is the property of skew-symmetric matrix? If the matrix is skew-symmetric, answer is null. Okay, if the matrix is skew-symmetric, then C dash would be equal to minus C. If the matrix is skew-symmetric, this would be the condition, that is C dash is equal to minus C. Sorry, this is the property of the skew-symmetric matrix, and X is a n cross 1 column matrix. X is a n cross 1 column matrix. So X dash would be a row matrix. Row matrix of 1 cross n. X dash would be row matrix of 1 cross n. So what we have to calculate is, we have to calculate X transpose C X. So it would be C. When we multiply this, it would be a matrix of 1 cross 1. X transpose C X, it would be a matrix of 1 cross 1. 1 cross 1. Okay. Now, let this X cross is equal to B. So B is a 1 cross 1 matrix. So 1 cross 1 matrix would be symmetric. If a matrix is symmetric, then B is equal to B dash. For a symmetric matrix, B is equal to B transpose, we can say B is equal to B dash. So let's see, we can equate X dash C. So B is equal to B dash is equal to B. We can write it like this. Okay, now we would be transposing both. Okay, then we would be having C. Then we would be having it like this. Okay, which would be equal to B. Wow, how? Let's see. If A B transpose is equal to B transpose A transpose. See, I have written it like X transpose C X whole transpose. Okay, first I would write this X, that is X transpose, then I would write C, that is C transpose, then I would write this, so X double transpose. So it is this, B double transpose is equal to B. Okay, now see, C transpose is minus C, sorry, C transpose is minus C. So I would be taking minus common. So it would be X transpose minus X transpose C X. which is equal to B. And see, this is equal to B. This is also equal to B. So it is minus B is equal to B. So we have 2B is equal to 0. So B is equal to 0. So it would be a null matrix of 1 cross 1. Null matrix of 1 cross 1. Okay. So actually this is a theorem. We many of us remember this, but this is how it is derived. Next. Consider the recurrence relation this, if n is greater than 0, okay. So we have to calculate this, how it is done, let's see. So we have Tn is equal to 2Tn minus 1. Okay, this is 1. If it is n is greater than equal to 0, for n is equal to 0, that is T of 0 is equal to 1. It is given, T of 0 is equal to 1. Okay, so now let's solve it. So for further expanding it, we would be having 2 into 2t n minus 2. So which would be equal to 2 square t of n minus 2. Okay, so and further if you go, it is 2 square 2 into t of n minus 3. So you would be having 2 cube t of n minus 3. Okay, and so on. It would be like 2 to the power k t of n minus k. Okay, this would be the final answer. So if t of 0 is equal to 1, so n minus k is equal to 0. So n is equal to k. If you put n is equal to k, that is k is equal to n, we would be having 2 to the power n. Okay, t of 0. So it would be equal to 2 to the power n. So our answer would be order of 2 to the power n. This is the answer. B should be answer. Okay, this is the answer. Okay, this is the answer. Next. This is a program and you have to find the complexity of a program. Okay, let's see. We have two loops over here, this and this. Okay, this loop is, we are just incrementing I and it is n by 2. So this loop, first loop, the outer loop would run n by 2 times. Okay, now the inner loop, see, it is into 2. Okay, into 2. So it would run log n times. Log n for inner loop. Sorry, inner loop. So our final complexity will be n by 2 log n or n log n. It's order of n log n. So answer should be D. So D is the answer. Okay. Next question. Match the following and choose the correct answer for the order A, B, C, D. Okay. So see, in this we have Straussian matrix multiplication. It is divide and conquer. Okay. And insertion sort, it is decrease and conquer, because it is decrease and conquer. Gauss elimination, it is, see, if you have any doubt, out of these 4, you would be knowing either 2. For example, I knew that Freud's shortest path algorithm is dynamic. Okay, this is dynamic, and Gaussian elimination is transform and conquer. So if you know 2 of them, then also you can solve the question. So this is the answer. So our answer is B here, RPSQ. Okay, so out of 4, if you know around 2, so then also you can solve. Next. For AB, the regular expression this denotes. So we have to see what it have. So when it is star, it is either 0 or more A's. So it can be no A or A or AA or AAA. Okay, but here now, here it is A star. But what we have is, we have AA star. Okay, our first thing, this one, A star. What does it mean? It can be null, or it can be AA, or it can be 4 times A, or it can be 6 times A. That is 0 or even number of A's, even A's. Okay, same for 0 of even A's for this. Okay, now for B we have B, B star and B. Okay, so here we can have, if it is 0, we can have B. If it is 1, we can have B, B, B. If it is 2, means 4, so we can have B, 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 B and B. So it is 1 or odd number of A's, odd B's. So it is set of strings with even number of A's followed by odd number of B's. Okay, it is not a multiple of 3 because we can have 5 also. Okay, so answer should be D. Set of A's followed by odd number of set of even number of A's followed by odd number of B's. So this was all about the second part. Please stay tuned and please subscribe if you haven't. Thank you.